discuss about periodicity. Okay, so there are 4 properties of periodicity, the 4 properties of elements in the periodic tables. Okay, so in terms of their atomic radii, and then we have ionization energy, and then electroaffinity, and last but not least would be electronegativity. Okay, all right. So for atomic radii and also ionic radii, we have discussed this during our last lecture last week. Okay, we have 2 factors that can affect the atomic and ionic radii. Okay, so one, it is called, guys, what is the first factor?
Z effective.
Yes. Okay, it is known as Z effective. Okay, so we have to describe the periodicity or the atomic radii of an element based on across the period dengan down the group. Okay, all right. So if we are talking about across the period, that means we have to highlight in terms of Z effective. Okay, we have to highlight based on Z effective. Okay, you have been introduced to how to calculate the Z effective. Okay, this is how we approximate the Z effective, the attraction felt by the valence electron. Okay, the attraction felt by the valence electron, and then that will be the Z effective. Okay, going across the period, and then we also have going down the group. So in terms of going down the group, what need to be highlighted, guys?
Shielding effect.
Shielding effect.
Yes. Okay, so when we go down the group, you need to highlight in terms of shielding effect. Okay, so as we go down the group, the principal quantum number increases ataupun the n increases. Okay, bila n increases, what does that mean? It means that the number of n, the number of shell increases. The number of shell increases means there are more electrons in the atoms. More electrons means more repulsion. More repulsion means more shielding effect, greater shielding effect, and cause the attraction to be weaker, and thus the size become larger. Okay, at the end of the day, it's all about the attraction of the nucleus and the valence electrons. Right? Okay, so we have that. We have learned that in our previous lecture. And then we have the general trend across the period dengan down the group. Okay, and then you have also been introduced to the ions, cation dengan anions. Okay, and then you have also been introduced to isoelectronic. Isoelectronic means species, chemical species having the same number of electrons. Okay, they have the same number of electrons, but in terms of size, they are not the same. We have to identify which one is the largest, which one is the smallest, and among others too, we have to identify, okay, we have to rearrange them in terms of their size. Okay, all right, so we have that already, we have learned that in our previous lecture. Okay, we have few checkpoints that we haven't discussed. Okay, let's go through the checkpoint. I assume that everybody has completed the checkpoint. Okay, this is like a week ago punya kerja, checkpoint. Okay, so siapa yang tak buat tu, you pandai-pandai lah, rasa bersalah lah sikit dalam hati tu. Okay, alright. Saya assume semua dah buat. Okay, now let's discuss the checkpoint. I think we have one more. Okay, this one. Checkpoint 10. Okay, alright. Using only the general trends in periodic table, arrange the element in order of decreasing atomic size. Decreasing maksudnya we're gonna start from the largest to the smallest. Okay, alright. So we have two criteria. It can be across the period dengan down the group. So we have to identify that first in order for us to know what to be highlighted. Okay, so what need to be highlighted? Okay, so we have calcium, magnesium, and beryllium. These three come from the same group. How do we know so? Okay, aside than kita refer to the periodic table other than that, okay, alternatively we could use the Z ataupun the proton number, the atomic number given here to construct the electronic configuration. Okay, and then from there we would be able to determine whether dia in the same period ataupun going down the group. Okay, so in short, calcium, kalau saya buat the partial orbital diagram, calcium come from group 2, right? And dia dekat N is equal to 4. Kalau tak tahu, try buat daripada 1s2, 2s2 and then you end up with 4s2. Okay, as for magnesium, okay, the highest N would be 3s2. Okay, start from the beginning and then the final N would be N is equal to 3. Same goes, bukan same goes. For beryllium, okay, beryllium, it has 4 electrons. Beryllium atom has 4 electrons. That means N is equal to 2, right? So 2s2. Okay, alright. So all of them come from the same group. Bila dia come from the same group, obviously dia bukan across the period lah. It must, must be going down the group. Okay, bila going down the group, we need to highlight in terms of shielding effect. Okay, even though it is not asked in the question, but you can always practice. Okay, practice. Walaupun dia tak minta, just to expose yourself with factors affecting the atomic size. Okay, alright. So this is based on shielding effect going down the group. So the largest would be calcium lah, because N is equal to 4. And then followed by magnesium and then beryllium. So the answer would be calcium is the largest, followed by magnesium, and lastly we have beryllium. This is in terms of if you were to explain what's the reason behind your arrangement, behind your list here, okay, you have to mention in terms of shielding effect. And furthermore, okay, kena explain lah further. It depends on the marks given, okay, alright. Shielding effect. And then for B, potassium, phosphorus and calcium, okay, again you have to make sure whether all these three come from the same period ataupun they come from the same group ataupun they come from different period or different group. Obviously potassium, phosphorus, calcium, they come from the same group at the different group. They come from different group. Okay, itu kita boleh confirm, and then we have to make sure whether they come from the same period or not. Okay, alright. So in order to make sure of this, you other than referring to the periodic table, okay, don't use. I mean, you can rely on periodic table, but remember, periodic table will not be given in the exam. Okay, alright. So the only way to find out if you tak hafal lagi dia punya period, dia punya group, that means you have to go for the electronic configuration. Okay, so for potassium, it is N is equal to 4. Tak percaya, start daripada 1s2 to s2 until you got 4s1. So in total should be 19. Okay, alright. So kita dapat 4s1 kan. So saya cut short saya nak cepat. Phosphorus come from period 3. Okay, you may start your electron configuration from 1s2 until you end up dengan all the 15 electron in the orbital. So you akan dapat 3s2 and 3p3. Phosphorus come from group 15. Okay, phosphorus come from the same group as nitrogen. Okay, and then we have calcium. Calcium come from group 2, and then the period is period 4, like we have in A just now. Okay, so it is 4s2. Okay, alright, so potassium and calcium come from the same period, but not for phosphorus. So obviously, phosphorus will be the smallest, will have the smallest size. Okay, but potassium dengan calcium, they come from the same period, kan? But in terms of this, we have to explain in terms of across the period based on Z effective. Okay, so across a period, Z effective increases. That means calcium has Z effective equal to +2, whereas potassium has Z effective equal to +1. Okay, so Z effective for calcium is higher than the Z effective for potassium. Therefore, calcium has smaller size compared to potassium. Okay, so how do we rearrange them? How do we arrange them in based on decreasing atomic size? Okay, so it should be potassium, the largest, followed by calcium, and last but not least will be phosphorus. Okay, all right. In terms of potassium and calcium, this is based on Z effective because they come from the same period. N is equal to 4. In terms of potassium, calcium, and phosphorus, okay, this group. So this we have to explain in terms of shielding effect. Okay, in terms of shielding effect. It can be a combination of both shielding effect and also Z effective. Okay, dia tak necessarily maksudnya macam A ni. Maksudnya they must come from the same group. Tak boleh macam tu. Senang sangat tu. Okay, it is predictable. So most of the time the question asked will be the combination of across a period and down the group. Okay, all right. And then next, for C, we have beryllium, calcium, and nitrogen. Okay, all right. So beryllium come from group 2, and the period is period 2 also. Okay, all right. So this is N is equal to 2 sebab dia punya partial electronic configuration would be 2s2. This is partial electronic configuration for beryllium. For calcium, it's 4s2. Okay. For nitrogen, the period will be the partial electronic configuration would be 2s2 2p4. 2s2 ya 4. Betul ke ni? 3 guys. 3. Okay, because kita ada 1s2. Okay, 1s2, 2s2, 2p, 3. Total kan it should be 7. Okay, so remember, this is the highest N. That means the nitrogen is located at period 2. N is equal to 2. This is also N is equal to 2. Okay, alright. That means nitrogen is located at the same period as beryllium. Okay, so in terms of beryllium dengan nitrogen, we have to compare based on across the period, which is based on Z effective. For calcium, obviously, the shielding effect because the highest N will be N is equal to 4. Okay, alright. So paling besar will be calcium lah. Calcium paling besar, followed by beryllium ke nitrogen. Beryllium ke nitrogen, guys?
Beryllium.
Okay, based on what? How do you know it's beryllium?
Z effective.
What's the Z effective for beryllium then?
+2.
Yes. How about nitrogen?
+5.
Yeah. Okay, very good. Okay, so the Z effective for beryllium is +2. The Z effective for nitrogen is +5. This is across the period. Okay, so across the period, so nitrogen having higher Z effective compared to beryllium. So beryllium, then we have nitrogen. Okay, all right. So this is based on Z effective, and this based on shielding effect. Right? Okay. Oh, and one reminder for you guys. There was one question from my morning lecture just now. Ada student tanya, can we instead of using this bigger than ataupun smaller than kan, instead of using that, can we use comma? Okay, alright. I would highly advise you not to use comma only. Okay, you can use comma, but you have to indicate. For example, if you have calcium, then you comma kan, then magnesium, and then comma, and then beryllium. Okay, alright. So don't just leave your answer as this. Jangan biarkan jawapan you macam ni. You have to indicate. Okay, so you have to indicate. Okay, from left to right ni, it is decreasing in size.
Madam,
Yep.
kalau buat anak panah,
Macam ni, calcium, magnesium, and beryllium. Okay, sama juga, you have to indicate. Okay, sebab saya boleh tanya, saya boleh query, apa maksud ni, arrow ni. Okay, arrow ni nak pergi mana? So you have to have indication for this. Okay, sebab apa you pakai koma-koma dekat situ? Sebab you assume that based on the question. Yes, it is true, it should be based on the question, but you have to make sure also that your answer, kalau dia stand alone, independent, without the question, okay, the examiners would still able to predict lah. Okay, your answer ni is based on question macam mana. Okay, that's why you have to have this indication. So kalau sebab when you use comma without the indication, it can be it can be anything, betul tak? Comma ni represent apa? Dan ke? Ataupun comma ni represent increasing in size ke? Decreasing in size ke? Ataupun tak ada represent apa-apa. Okay, just tulis je. Okay, so the best way is to indicate. Use arrow and then describe dekat bawah tu. Indication. Okay, whether it is decreasing, increasing, or whatever lah. Usually it can only be decreasing or increasing. Okay, right. Have indication, okay, in your answer. Right. Okay, that will be it. And then we have one question related to ions. Okay. Arrange each set of ions in order of decreasing size and explain your answer. Okay, alright, so calcium 2+, beryllium 2+, magnesium 2+. Okay, so by right, all the representative elements, especially group 1, group 2, 17, 18, 15, 16, 13, 14, okay, all the representative elements, especially period 1 until period 3. Okay, you dah kena memorize lah. Okay, you kena memorize. Okay, especially group 1, group 2, 17, 18. Okay, alright. So calcium, beryllium 2+, magnesium 2+, they come from the same group, but all of them are in ion state. Okay, in cation state. Alright. Again, you can predict based on the Z given, okay, based on the electronic configuration given, but guys, please be careful. Okay, the Z given is also represent the number of electron, right? But this is for the atom. Okay, please take note on this. The Z given represent the number of electron for atom. Bila dia dah jadi ion, do not forget to minus. Kalau in this case it's cation kan, please do not forget to minus with the number of charge for the cation. Okay, alright. Please remember, please, this is very basic. When it is in neutral atom state, the Z or the proton number is equal to the number of electron. Okay, if it is a neutral atom. Bila dia dah jadi ion, okay, it's no longer the same as Z. Dia adalah number of electron. So that means if you want to know the number of electron of calcium 2+, that means 20 minus 2, it will be 18. When you construct your electron configuration, it should be based on this, 18 electron. Okay? Right. So remember, jangan salah pakai. Maksudnya you nampak calcium 2+, you pun pakai, the number of electron for calcium 2+ is 20. Sorry, salah ya. Okay, itu kena jentik telinga. Same goes to beryllium 2+. This Z is equal to 4 is for beryllium atom. not for beryllium 2 plus. So in order to know the number of electron for beryllium 2 plus, you have to minus with 2. So it should be 2. The number of electron for beryllium 2 plus would be 2, guys. Same goes to Mg2 plus. You have to minus with 2. 12 minus 2 would be 10. Okay? Alright, so this is obviously the same group. So they're going down the group lah kan. Bila going down the group, as you can see, all the ions having the same charge. So macam kita boleh assume yang dia dalam keadaan atom pun tak ada masalah. Okay, sebab dia datang daripada the same group. Okay, so obviously ni based on shielding effect lah. This is based on shielding effect. Sebab kalau dia jadi this one, kalau lah iris calcium 2 plus, once they become ions, dia akan jadi, this is a partial electron configuration for calcium 2 plus, it would be 3s2 3p6. Bila dia dah buang, kan dia ada 4s2 kan? Ni kan dah kena buang, so 0 lah. Okay, so dia become 3s2 3p6. This is for calcium 2 plus. For beryllium 2 plus pula, it will become 2s2. Okay, 2s2. And then for magnesium, beryllium dia jadi macam helium kan, duplet dekat situ. Magnesium 2 plus on the other hand, dia period 3 kan, so dia become 2 when the 2s2 2p6. Okay, 2s2 2p6. Kalau magnesium atom dia kan 3s2. So when this 2 has been removed, so there's no electron in the 3s orbital. So here is the highest end for magnesium 2 plus. Okay, this is the partial electron configuration for Mg2 plus. So as you can see, sorry guys, ni 1s2. Okay, it should be 1s2. Sebab, it should be 1s2. Okay, tegurlah saya. Kalau saya salah, tegur. Okay, this one, kalau dia dah jadi beryllium 2 plus, it will become 1s2. Sebab, kalau beryllium atom, it should be like this. 1s2, 2s2. 2 plus 2 is equal to 4. So, ini dah remove. So, we have 1s2 only. Okay, alright. So, as you can see, the highest end will be 3. For calcium, the highest, for beryllium 2 plus, the highest end will be 1, n is equal to 1. The highest end for magnesium 2 plus will be n is equal to 2. So, going down the group based on shielding effect. Okay, alright. So, if we were to arrange them, so the largest will be calcium 2 plus, followed by magnesium 2 plus, and then beryllium 2 plus. Okay. This is due to shielding effect. Across the period, maksudnya you have to mention in terms of going down the group. Okay, shielding effect increases due to the number of electron. Ataupun going down the group, the n increases. Okay, the n increases, ni 3, ni 2, ni 1 tadi kan. The n increases. The number of electron also increases, okay, and the shielding effect also increase, which cause the size to become larger. Okay, alright. Okay, so let's go for B. K plus, S2 minus, and Cl minus. Okay, all these three, as you can see, so apakah kategori K plus, S2 minus dengan Cl minus ni guys? Kita boleh groupkan all these ions into one group that is called as, apa nama dia?
Isoelectronic.
Okay, good. Okay?
Isoelectronic.
Isoelectronic. Okay? Bagus. So K plus, S2 minus and Cl minus, they are isoelectronic. Why? Because they have the same number of electron. Kalau again, nampak you tak akan perasan ni kalau you based on set the original electron number of the atom or of the respective atom. Okay, so this Z belongs to K atom, and Z for sulfur, this is Z for sulfur, and this is Z for Cl atom. Okay, so as you can see, dia punya Z berbeza lah. Tapi macam mana dia boleh dapat sama? You have to consider tu if they form ions. So Z is equal to 19 is for K atom, potassium atom. Bila they become K plus, okay, the number of electron will become
18.
Same goes to S2 minus. Okay, bila dia jadi S2 minus, don't forget to add ataupun total the electron added. So S accepts 2 electron dekat situ. So 16 plus 2 would be 18. Okay, chlorine also become chloride. Okay, so it accepts 1 electron, so Cl minus. So 17 plus 1 is equal to 18. See? Nampak tak? Baru you nampak that the value, the number of electrons are the same. Therefore, they are all isoelectronic with one another. Okay? Alright. So in terms of isoelectronic ni, kita kena based on apa nama tu, the number of electrons added ataupun removed. Okay? Alright. So we can also be based on what do we call that, across the period lah. Okay, alright. So S2 minus dengan Cl minus. Paling senang, let's look at for the cation lah. The N ion. Okay, the N ion. The more it accepts electron, the more shielding effect it has. Okay, so S2 minus, tukar kali lain. S2 minus, the Z effective would be positive 6. Cl minus, the Z effective is positive 7. It will not change the Z effective for S2 minus dengan Cl minus. Because why? Okay, the electrons are added in the valence shell. Dia letak dekat valence shell. In order to calculate Z effective, you kena ada Z minus dengan core. Kalau electrons are added, will it affect the core electron, the number of core electron? No. Core electron tetap remain sama. Yang bertambah adalah valence. That is why for N ion, the Z effective is not affected. It will remain the same. It's just that now, the repulsion is greater. Sebab ada pertambahan elektron dekat situ. So the more electrons are added, the higher the repulsion or the higher the shielding effect. Okay, dah lah S2 minus ni accept 2 elektron. Lepas tu the Z effective pula lebih rendah from the Cl minus. Okay, alright. So obviously S2 minus will be the largest, followed by Cl minus. Okay, alright. In terms of K plus, okay, let me show you how to calculate the Z effective for K plus. Okay, for cation ion, the Z effective will be different. The Z effective will be different. Okay, let's see. K, this is for the atom. The what we call that electronic configuration will be 1s2, 2s2, 2p6, 2, 3s2. Okay, 1, 2, 3s2, 3p6, 4s1. Okay, so let's total up. So 10, 18, 19. Okay, because the Z for the proton number for potassium is 19. Okay, when it becomes ion, dia akan buang this one, right? So one of the valence electron will be removed. Okay, 1s2, 2s2, 2p6, 3s2, 3p6. Okay, so there you go for K plus electronic configuration. Okay, how do we calculate the Z effective for K? As you can see, okay, the valence shell is now changed to N is equal to 3 now. Nampak tak? So the number of core electron is now on this one. Tadi, for potassium tadi, the number of core electron, we have 1s2, 2s2, 2p6, 3s2, and 3p6. This will be the number of core electron. Okay, cuba kita kira untuk potassium. Potassium, the Z effective would be 19 minus the core electron. Okay, 19 minus 1 jadi 18 lah. Okay, so the answer would be positive 1. Okay, kalau nak kira lah. Kalau tak, kita boleh tahu it's positive 1. Okay, how do we calculate the Z effective for K+? Okay, sama juga 19 sebab Z minus the core electron kan. Okay, for now, okay, for K+, the core electron is now, we have 10. 10 sahaja dekat situ. Because this is now our new valence shell and valence electron. Okay, so that's why 19 minus 10. So, nampak tak berapa? From positive 1 becoming positive 9. Dah lah buang elektron, the electron has been removed, and not only that, the Z effective is now very, very large ataupun is greater, okay, than the parent atom ataupun the potassium atom itself. Bila dia jadi ion, dia become positive 9. Bila dia jadi bila dia atom, dia hanya positive 1. Okay, alright. So that is one of the reason why potassium plus, okay, potassium plus is the smallest. Okay, so what need to be highlighted? Like I said, satu, in terms of S2 minus dengan Cl minus, you have to highlight in terms of Z effective. Okay, Z effective for chloride is higher ataupun greater than S2 minus. That is number 1. Number 2, you have to highlight in terms of the number of electron accepted. Number of electron accepted. Okay, sebab the more electron accepted in the atom, the higher ataupun the greater the shielding effect. Therefore, the attraction will become lesser ataupun weaker, and thus the size become larger. Okay, alright. So in terms of this one dengan K+, okay, the anions and the cation, you have to mention in terms of Z effective, obviously. Okay, you have to prove it, you have to calculate Z effective. It is equal to positive 9. Okay, and then again, you have to mention in terms of number of electron removed. Less electron means less shielding effect. Less shielding effect means stronger attraction. Stronger attraction cause the size to become smaller. Okay, get the logic first. Dapatkan logic tu. The rest tu you pandailah karang. Okay. Okay, so ni jawapan dia. So you have to mention in terms of isoelectronic. That will be 1 mark. Okay, ini dapat 1 markah dekat situ. So as you can see, based on the answer given here, saya pun tak satisfy on the answer given here because you have to explain your answer. Okay, this is not explaining. This is stating the trend. Okay, ini bukan jawapan yang kita cari. So please, this is what I have mentioned here. You kena take note lah on the answer that need to be highlighted. Okay, so ini bukan jawapan yang kita cari. Tapi one good thing, walaupun dia tak bagi jawapan tu, you kena lebih prepared lah. Okay, you have to be aware that this is not the answer that we are looking for. Unless dia mention pasal explain the trend. Even the word explain itself pun, you have to include the reason why why the arrangement is as such. Okay, you have to describe, you have to explain that. Okay, so stating the trend usually tak dapat markah pun. Okay, because nak tak nak kita memang akan terstate the trend. Okay, alright. So that's why normally tak ada markah for trend tu. Dia across the period increases. Dia tak represent apa-apa. Across the period increases due to Z effective and blah 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 blah. Tu ada markah. Okay?
Madam.
Yep.
Nak make sure, adakah semua anion lagi besar pada ion ke ikut?
Macam mana?
Adakah semua anion lagi besar pada cation ke ikut juga?
Ikut juga. Okay, dia ikut juga dia duduk dekat mana. Sebab kalau dia N is equal to 6, dia cation ion, N is equal to 6. Tapi N ion ni dia N is equal to 2. Kan? Kat situ size tu dah besar walaupun the electron has been removed. But tadi cat N ion tadi tu dia duduk dekat N is equal to 2. Okay, N is equal to 3. So dia ada, you kena consider juga benda-benda macam tu. Okay, so normally lah kita tak bagi yang, kita ada what do we call that, contradict effect. Dia cancel off tau. Dia ni dia accept electron, the Z effective is higher. Tapi this one dia remove electron but the N is larger, the N is bigger kan. Dekat situ kita nak consider apa? Itu sometimes dia ada cancellation effect dekat situ. Dulu used to have that question. Maksudnya there's no effect in terms of size. Dululah. But nowadays kita dah tak buat dah style macam tu dah. Okay, kita tak buat that cancellation effect. Kita tak highlight. Kita ada that criteria but we don't highlight it in our syllabus. Okay, again you have to make sure you kena consider how do we do that. You kena look from the electronic configuration from the highest end in order for you to determine which period that they come from ataupun which group that they belongs to. Okay, alright, any other question guys? Ada lagi. Okay, for each of the following pairs, choose a species that larger in size and explain your choice. Okay, alright, so A, N3 minus and F minus. So what will be the answer for this one guys? N3 minus dengan F minus is considered as?
Isoelectronic.
Yes, again, isoelectronic. How do we know so? Kena buatlah electronic configuration. Okay, nitrogen, fluorine, oxygen. Okay, dia ni FON ni, dia in the same period. They come from the same period. Okay, these three are among the the most electronegative atom in the periodic table. Okay, FON, they come from the same period. Okay, so what need to be highlighted for this one? Apa yang kita nak highlight kan kalau nak explain your choice? Guys?
Z effective.
Yes, in terms of Z effective. And then one more thing, lagi satu that you need to highlight. What is it about?
Number of electrons accepted.
Yes, very good. Okay. Okay, macam how do we differentiate kalau you nak cakap in terms of Z effective kan, which is not wrong. Okay, which is not wrong. Tapi how do we differentiate with this one? N or F? You tahu? Yes, N or F. Which one has larger in size? Which also jawapan dia Z effective, betul tak? So macam mana kita nak differentiate these ions dengan this one? Okay, ada extra information that you have to add in there. Okay, yes, it is true. You have to highlight in terms of Z effective. The Z effective for nitrogen is +5 and the fluorine, the Z effective is +7. Betul. Kena tambahlah sikit sebab this is ion kan. We are talking about ions kan. So you have to mention in terms of Z effective. Secondly, you have to mention in terms of number of electron accepted. The more electrons accepted into the atom, by right, the higher the shielding effect. The shielding effect causes the attraction between nucleus and valence electron to become weaker and therefore the size become larger. Alah. Okay, benda yang sama. Okay, so highlight this one Z effective and also number of electron accepted. Okay, kalau it involve ions, please highlight the number of electron ataupun the number of electron accepted or removed. Okay, kena highlight that one, right? Okay, so magnesium 2+ or calcium 2+. Okay, ini nak kena mention in terms of apa ni guys? Anyone?
Shielding effect.
Shielding effect. Kenapa shielding effect?
Same group.
Yes, okay, because they come from the same group. Kita tak, I mean in terms of the charge, as you can see, dia punya charge dia sama. They remove 2 electron. Okay, both of them remove 2 of its electron. So tak boleh not significant lah, tak boleh nak compare in terms of that. So dia macam lebih kurang sama kalau magnesium dengan calcium. Right? Okay, so you kena mention in terms of one is shielding effect. Kenapa shielding effect? Because we are going down the group. Bila going down the group, the N increases, betul tak? So calcium has higher N compared to magnesium. Okay, so higher N means more electron means blah 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 blah, yang sama lah. Okay, and then do not forget to highlight the Z effective. Okay, Z effective dia berubah tak? Berubah kan? Rasa berubah. Shielding effect pun dah good enough lah. Good enough. Okay, shielding effect. But Z effective, just to calculate, cuba kita try calculate. Z effective for magnesium. Apa nama tu? Magnesium 3s2 kan. So kita ada 10 dekat situ. 10 electron. Magnesium 2 plus 9, 10 dekat situ. So dia jadi 2p6 2s2 1s2. Betul tak? Okay. Ini Mg2 plus, okay? Kalau kita nak 12, dia punya Z effective will be 12 minus the core electron untuk Mg2 plus. Mg2 plus dia tolak 2. Because this is now the valence. Valence guys. Sebab dah buang this one tadi. Dah buang. Okay, 12 minus 2 is equal to 10 plus 10. Okay, alright, tak boleh. Maksudnya Z effective in terms of Z effective dia tetap sama. Okay, calcium pun akan dapat positive 10 juga. Okay, in terms of Z effective it will be the same. Tu tak sesuai lah. It's not that significant. So the most significant factor is shielding effect going down the. Okay. Alright, in terms of C, okay, Fe2 plus or Fe3 plus, this is based on the number of electron removed. Okay, the more, the higher the number of electron removed, this is obvious, nampak? 3 plus dengan 2 plus. So 3 plus remove more electron than 2 plus. By right, Fe3 plus has lesser shielding effect. Lesser shielding effect means,
smaller size.
In terms of attraction, lesser shielding effect means weaker. Okay, weaker attraction between nucleus and valence, and the size become larger. Okay, ini kena highlight number of electron removed. Okay, right. Yep, this is again, like I said, isoelectronic. Okay, so results in they mention apa ni? Z effective. Like I said just now, kena highlight in terms of Z effective, tapi nampak tak dia tak highlight in terms of the number of electron accepted. See, jawapan tak bagi. So you tambah dekat situ. Take note on this. Okay guys. Okay, calcium 2 plus, Mg2 plus, different principal quantum number. Calcium 2 plus, the ion N is equal to 4. Is it true? Okay, for calcium 2 plus, it's not N is equal to 4 anymore. Dia dah jadi N is equal to 3, betul tak? Okay, so kalau calcium, N is equal to 4. Once it become calcium 2 plus, they become N is equal to 3, kan? Betul tak? This one, when they become Mg2 plus, N is equal to 2. No longer N is equal to 3. N is equal to 3 is for magnesium. Tapi as you can see, dia berkurang sebanyak 1 juga. Okay, this is Mg2 plus, this is calcium 2 plus. For calcium, it is 4. Okay, N is equal to 4. Magnesium, N is equal to 3. Itu sama juga lah, dia punya gap dia tu still 1. So that's why we can still use different in quantum number. Okay, Cuma ni tak represent okay. So please take note on this. Okay. Bila dia dah jadi ion, especially for cation, dia dah buang elektron. So the orbital is now vacant ataupun empty. There's no electron in the valence shell. So kita ada next valence shell. Yang tadi core tu dia dah jadi valence. Okay? Alright. Fe2 plus dengan Fe3 plus both have the same Z effective. But Fe2 plus has greater electron repulsion due to extra electron. Okay? Due to the number of electron removed tadi. Okay? You may mention in terms of this greater number of electron for Fe2 plus. Sorry. Or you can also mention in terms of the number of electron removed. Okay? Alright, okay. Lamanya kita discuss untuk checkpoint. Okay? So next will be ionization energy. Supposedly this week kita kena start topic 3 guys. Kita topic 2 pun we not even finish yet. Okay? So agak stressful dekat saya dekat situ Okay, alright, so we are done with atomic size. Now let's move on to ionization energy. And then we have two more, okay, which is electron affinity and electronegativity. Okay, and this is our checklist. So we are done with the size. Next will be ionization energy. Sorry. So as you can see, we have quite a number of learning objectives for ionization energy alone. Okay, so make sure that you completed all this learning objective, okay, at the end of this subtopic. Okay. So what is IE? Ionization energy. Energy to ionize. Okay, energy needed to ionize. So that is in short. Okay, so we know that ionize means energy needed to remove electron in order for the atom to become ion. Okay, in simpler way to describe ionization energy or IE. Okay, alright. In proper definition, IE is the minimum energy required to remove 1 mole electron. It should be 1 mole. It cannot be 2 mole, 3 mole, and whatnot. It should be 1 mole of electron from 1 mole of atom or ion in the gaseous state. Okay, you need to have all of these keywords in order for you to get 1 mark. Okay, and this gaseous state is very important even though you have all 1 mole electron from 1 mole of atom or ion, but without the gaseous state, your answer will be wrong. Okay, because the elements or the atom need to be in gaseous state. It cannot be in a solid state, liquid state, or whatever. It must be in gaseous state. Okay. Alright, so that is the definition of ionization energy. Minimum energy required to remove 1 mole electron from 1 mole of atom or 1 mole of ion in the gaseous state. Okay, alright, so the greater the ionization energy of an atom, the higher the atom tendency to retain its electron. Okay, alright, maksudnya if the ionization energy is higher ataupun greater, what does that mean? Apa maksudnya? Maksudnya, more energy is needed to remove the electron from the atom. Maksudnya, nukleus tu punya attraction dengan valence electron is very, very strong. Okay? In order to overcome the attraction, the energy required would be very, very high. Okay? So, kita boleh conclude that the greater the ionization energy, it means the attraction, okay, is stronger between the nucleus and the electron. Ataupun the higher the atom tendency to retain its electron, dia pegang the electron. Okay, alright. So there are factors that can affect that can affect the IE. Okay, so similar to the one that we have for atomic size. Okay, so ini kita ada additional factor guys tu, which is atomic radii guys tu. Okay, but we know that atomic radii depends on shielding effect and effective nuclear charge. Okay, remember at the end of the day, it all depends on the attraction between nucleus dengan valence electron. So this attraction cause the variation, okay, in terms of size, ionization energy, electron affinity, and electronegativity. Okay, all right. Okay, so this is in terms of diagram, okay, simple illustration on how to describe ionization energy. So imagine this is the nucleus, it is positively charged. Okay, this nucleus attracts all the electron and cause the electron to be in place. Maksudnya dia tak pergi merayau-rayau dekat region-region lain lah. Okay, alright. So this will be the valence shell kan. Therefore, this is the valence electron. So ionization energy means the energy needed to remove ataupun to release this electron, to remove the electron out from the atom. Okay, alright. So logically speaking lah, saya cakap dengan awak kita ada across the period dengan down the group. Okay, so factors affecting IE dia sama saja macam factors affecting atomic size. Okay, across the period. Okay, dapatkan logik je. Across the period, the Z effective increases. Betul tak? Z effective increases. Bila Z effective increases, the attraction between nucleus and valence electron become stronger. Bila stronger, okay, the electrons are held tightly ataupun dipegang secara kuat. Okay, they will be pulled inward, dia tertarik ke dalam and cause the size to become smaller. Betul tak? The size become smaller. Kalau the attraction is so strong, is it difficult or is it easier to remove the electron out from the atom? Difficult. Yes. It will be very, very hard. Okay, it will be very hard. Kalau susah nak remove the electron, maksudnya is it greater ke ataupun is it lower in terms of the ionization energy?
Greater.
Okay, so janganlah terconfuse dekat situ jangan terconfuse sebab ada je student dia tahu attraction is strong but in terms of ionization energy is decrease. Okay, tu confuse lah tu. Okay, so kalau stronger attraction, that means more energy. So imagine more energy is needed to remove the electron. More energy means greater ionization energy. Right? Okay, so as simple as that. So with that, belum lagi, okay. Okay, this is the general term for IE. Okay, ionization energy. So this is the general definition. Okay, we have a specific one. So we have first ionization energy, in fact we have second, third, fourth and so on. Okay, what is the difference between all of this ionization energy? Kalau first ionization energy, first kan nak remove the first valence electron. Okay, the minimum energy required to remove 1 mole of electron in a valence shell from 1 mole of gaseous atom. Ini tambahan dia. Gaseous atom in its ground state. So the ground state tu nak shows that the atom is not in excited state. So that's why opposite to excited state is ground state. Kita tak belajar pun excited state. Okay, so let's just have ground state there. Okay, ground state maksudnya dalam keadaan normal lah, without excitation. Okay, so tambahan dia, everything is the same as what we have in the earlier slide. Tambahan dia dekat sini, to remove one mole of electron in a valence shell, ataupun sometimes to remove the first 1 mole of valence electron. Okay, from 1 mole of atom in gaseous state. Okay, you may rearrange macam biasa untuk memudahkan you ingat, you boleh rearrange as long as all the keywords are there. Okay, minimum energy required to remove 1 mole of valence electron. Okay, bila dah ada valence electron maksudnya daripada valence shell lah. Betul tak? 1 mole of valence electron from 1 mole of atom, 1 mole of atom in gaseous state. Boleh juga. Okay, you may have that also. as your definition regardless, okay? Alright, so make sure that all the infos should be there in order for you to be awarded with one mark. Alright, so how do we write the chemical equation to represent the first ionization energy? Okay, so based on the definition that we have just now, the electron should be removed from the atom. So this is the atom and it should be in gaseous state. Okay, alright, so this is the elements in atom state. Sebenarnya dia macam ni. M, gas kan? Dalam keadaan gas, buang satu elektron. Betul tak? Satu mole of electron becoming M plus in gas state. Okay, but normally in chemistry we do not use minus. Perasan tak? Kita tak guna minus tapi kita guna tambah saja. Right? So to change this into plus, kita pindah to the other side, so it becomes Mg plus M plus in gas state, okay, plus electron. This is first IE. How about second ionization energy? Okay, kita ada slides on this later, but just to give you apa nama tu, a heads up, maksudnya nak bagi you, nak introduce you awal lah, so that later you dengar lagi, the more you listen, the more you hear, the better you remember, ataupun the better you memorize. Okay, alright, so kalau nak second ionization energy, so it should be from M plus. Okay, so dia akan jadi M plus, buang elektron, so dia pindah di other side, so dia akan jadi later on M2 plus in gas state plus electron. This is what we call second IE. Okay, so this is first ionization energy, this is second ionization energy, this is first, this is second. And how about third ionization energy? Sama. So what can we conclude from this? Okay, that ionization energy, ionization need to be done stepwise. Dia adalah step by step punya proses. You tak boleh combine. Okay, katakanlah soalan suruh you write the chemical equation for the third ionization energy. Okay, for the third ionization energy. So you pun bukan main, okay, Mg, buang 3 elektron, so dia akan jadi M3 plus in gas state become plus 3 electron. Okay, this is wrong. It need to be done stepwise. Maksudnya kalau nak tunjuk third ionization energy, it should be from M2 plus, okay, M2 plus will become the reactant here in gas state becoming M3 plus gas, okay, plus electron. Nampak tak? This step by step. Satu elektron, and so on. So this is the third ionization energy. Okay? Alright. So the most safest way, if you will ask, katakanlah successive ionization energy, this is what we call berturutan. Okay? Kalau dia suruh you buat write the chemical equation for the fourth ionization energy, I would highly advise you to start from the start, from the atom itself. Okay, from the atom itself, okay, this is IE1, this is IE2, IE3 sampai IE4, so that you can see, you boleh nampak. Okay, unless you dah terror betul, okay, you dah tahu IE4, oh terus, maksudnya you boleh tahu terus ME, it should come from M3 plus. Okay, jadi M4 plus, okay, plus 1 electron. This is what we call IE4. Okay, boleh tak munasabah, tak mustahil, it's not impossible. Okay, as long as you know that it should be done stepwise. So it should be from 3 plus becoming 4 plus. Kalau tak, I would highly advise you to start from the first, second, third, and so on. Okay, and then highlight that one. Highlight the one that asked by the question. Okay. Alright, guys. General, what do we call this? General trend lah. Okay, general trend. So like I said just now, okay, we have across the period dengan down the group. Okay, sama je. So across the period, you may use this as your reference or you can construct on your own. You boleh construct on your own. Okay, tanpa tengok let's just not look to the slide. Kita tak refer the slide. Okay, let's just use whatever we had learned before this. Okay, to construct the trend ataupun the reason why the IE varies across the period dengan down the group. Alright, okay, so across the period, the Z effective increases. Okay, kalau dekat sini as you can see, dia highlight the atomic radii dulu. The atomic dulu dia highlight. Kalau saya, I would prefer to go for Z effective dulu. Okay, because the Z effective determines the size and it determines the ionization energy. Okay, but regardless, make sure that you have all the information in your answer. Okay, kalau based on saya punya answer, across the period, the Z effective increases. Bila Z effective increases, okay, the attraction between nucleus and valence electron becomes stronger. And this cause the attraction dah tadi kan, this cause the size to become smaller. Okay, because they are held tightly by the nucleus. Okay, this causes the size to become smaller and they are held tightly, okay, strongly with the nucleus. It causes the ionization energy ataupun the energy needed to remove the electron will become higher. Okay, so across the period, the size decreases, the ionization increases. Nampak tak? Opposite trend Okay, opposite trend. Okay, down the group, cara yang sama. Down the group, the number of N increases. Okay, bila the number of N increases, the shielding effect increases. Betul tak? Shielding effect increases. Bila shielding effect increases, the attraction become weaker. Okay, bila become weaker, how about the size? The size become larger. Bila size become larger, attraction become weaker. Is it difficult ataupun is it easier to remove the electron? Easier. Yeah. Should be senang lah nak remove sebab dah attraction tu dah decrease ataupun reduce ataupun smaller. Okay? Alright. So all of the information tadi sama je dengan what we have in this paragraph. Okay? Don't forget to highlight the attraction between nucleus and the valence electron. Okay? Alright. So, okay, we have a note here. Atoms with low ionization energy tend to form cation. Atom with a high ionization energy tend to form anions because they are difficult to ionize except for noble gas. Okay, noble gas will not ionize at all because noble gas has reached stable electron configuration. That's why they accept the noble gas. Okay, even though dia duduk dekat group block P kat situ. Okay, it will not ionize because dia dah stable. Okay, alright. Kenapa dia kata atoms with low ionization energy tend to form cation? Okay. We know that group 1 and group 2, right? So group 1 and group 2, we know that they tend to form cation. Okay, kenapa? Kenapa they tend to form cation? Because they have low ionization energy. Okay, they have low ionization energy. Maksudnya energy, yelah dia duduk dekat belah kiri kan. So across the period, Z effective increases. So by right, group 1, group 2 has the smallest group Z effective, betul tak? So Z effective dia paling rendah. Bila paling rendah, that means the attraction dengan the valence tu yang paling lemah. Yang paling lemah. Bila paling lemah, the IE ataupun the energy needed to remove the electron will be smaller. Okay, will be lesser sebab dia punya Z effective dia rendah. Okay, that is why group 1 and group 2, they tend to form cation. It is easier to form cation. Senang, lebih mudah to remove rather than to accept electron in order to become stable, nak achieve the octet tu. Okay, remember, dia nak jadi octet, dia nak jadi macam everybody want to become like noble gas. They want to achieve the stable electronic configuration as what we have for noble gases. Okay, alright, so one of the way for group 1 and group 2, they prefer to form cation, maksudnya they remove electron because that is the easiest, because it only requires low ionization energy. Okay, as for an ion, kenapa they prefer to form an ion rather than cation? For example, group 17, group 16. Why do they prefer to form an ion in order to become ataupun in order to reach octet ataupun stable electron configuration? Kenapa? Tak wonder. Wah, soalan. Okay, kenapa they tend to form an ion? It's because of the ionization energy. Okay, imagine if they were to accept, they were to remove electron. Okay, they were to remove electron. Across the period, we know that they have Z effective, higher Z effective, kan? Betul tak? Z effective, they have higher Z effective atau greater Z effective. Greater Z effective means it will be harder to remove the electron. Okay, instead, dia terlampau kuat. The Z effective is very strong. Not only it can attract all the electron, it can also attract the electron from outside. Faham tak? Z effective tu terlampau besar. Okay, macam group 17, group 16, group 15. Okay, kan dia punya Z effective positive 5, positive 6, positive 7. Powerful enough. Not only it can attract the electron inside the atom, it can also attract the electron from outside. So kalau dah attraction dah sangat kuat, the energy required to remove the electron would be higher. Terlampau susah nak remove the electron. Okay, so instead of removing, why not accept electron? Okay, dia still boleh achieve the stable electronic configuration macam noble gas. Okay, that is why an ion, group 15, 16, 17, they prefer to accept electron rather than to remove electron. Faham tak? Kalau nak remove electron, energy needed will be higher. Okay, that is why an ions has higher ionization energy. Okay, because they are difficult to ionize. Daripada nak buang elektron tu, baiklah accept electron and become an ions due to high ionization energy. Tudung saya ni dah macam apa ni? Okay, right. Okay, so this is the general trend. Across the period, down the group, across the period, across the period, the ionization energy increases due to ZF, okay? Down the group, down the group, the ionization energy, the first ionization energy, okay? The first ionization decrease due to shielding effect. Kena highlight juga and increases, therefore shielding effect increases and the size become larger, therefore ionization energy become smaller. Okay. Alright, so this is just to highlight, okay, this is the trend. Tapi the trend ni dia include the ionization energy, the first ionization energy for all the elements, main group element. Okay, for all the main group element, group 1, group 2, 13, 14, 15, 16, 17 and 18. Okay, alright, just to highlight to you, okay, let's focus on N is equal to 2 lah. Sebab N is equal to 1, kita ada hydrogen and helium only. Okay, so let's start with N is equal to 2. Okay, remember, trend dia macam mana? Across the period, sepatutnya general trend. Across the period, supposedly it should be increasing. Okay, cuba kita tengok, starting from lithium, okay. So we have lithium, and then beryllium, okay, they still follow trend, okay, follow trend, group 1, group 2. Then suddenly untuk boron, which is group 13, this is in the same period, okay. This is for the same period, this is 1, 2, 13, 14, 15, 16, 17 and 18. Okay, lithium, beryllium, and then suddenly untuk group 13, dia ada dip guys, dia turun from 899 becoming 800. Dah pula. Okay. Alright, cuba tengok lagi. Boron and then carbon. Okay, carbon dia starts to go up, dia dah naik balik, okay, follow trend balik, follow trend, and then nitrogen pun naik lagi, okay, still follow the trend, and then from nitrogen to oxygen, then suddenly dia apa nama tu, dia decrease lah pula. Okay, kenapa dia decrease dekat situ? And then for fluorine, okay, they follow trend balik, dia increasing. And then neon, dia increasing. Okay, so this is what we call abnormality. Okay, abnormality or anomaly. Okay, like what we had learned in the earlier slide. In the earlier slide yang pasal chromium dengan copper tu, anomaly tu kan. Okay, so this is also the same. So we have abnormality yang tak follow the regular trend, and we will look at why, okay, in the later slide. Okay, just to highlight, okay, kenapa dia tak follow trend. Sepatutnya increasing lah, tiba-tiba jatuh pula, lepas tu increase balik, and then increase, and then suddenly goes down, and then increase balik. Okay, so there's a reason why for that. Anomaly ataupun abnormality. Okay, chemistry banyak sangat abnormality. Dia tak semestinya follow trend. Okay, alright. Ni in terms of the graph, nampak tak? Okay, ni period 2 okay. This is period 2. Nampak tak? Lithium, okay, increasing. This is 1, 2, 13, 14, 15, 16, 17 and 18. Nampak tak? 1, 2 dah increasing dah maksudnya. And then suddenly for 13 dia decrease. Then for 14, okay, they goes back to normal. 14 to 15, okay, and then from 15 dia goes down. Okay, dia turun balik, and then suddenly for 17 dia goes up, and then 18 goes even higher. Okay, alright, so we want to know what actually happened here. Okay. Tiba-tiba ada soalan Arrange the element in each of the following sets in order of decreasing ionic, increasing of ionic ionization energy. The first ionization energy. Okay, alright. So I give you 2 minutes for you to do, for you to complete. 3 minutes for you to complete this checkpoint. Okay, later I'll call up names for you to read out your answer. Okay, alright. Okay, please complete this checkpoint, guys. Do you have question? Ada question ke so far? Are you guys doing okay there? So far so good ke?
Okay.
Seorang ni wakil daripada berapa 50 orang. Menengok sikit. How many of you? So we have 52. How about others?
Okay.
Yeah.
Okay.
Okay. Saya percaya kat awak ni tau. Kau tiba-tiba tak okay pula. Siap. This is the time for you to ask, okay? So kalau you tak tanya kat ni masa tutorial, tiba-tiba you kata tak tahu, geram. Saya geram macam tu. Okay? Saya geram. Gaya macam tahu. So sikit pun awak tak faham, tanya. Please ask. Okay. Okay, let's have Shahi Izzat.
Yes, madam.
Okay, Shahi, arrange the element in each of the following sets in order of decreasing IE1. Okay, all right. So what will be your answer for this?
Helium, neon, argon.
Let me share the screen first. Okay. In order of decreasing first ionization energy, that means we're going to start from the greatest first ionization energy, okay, and last with the smallest ionization energy. So the greatest will be
Helium.
helium, right? And then
Neon.
right, okay, neon, and lastly we have
Argon.
argon. Okay, so they come from do they come from the same period or do they come from the same group?
Same group.
Okay, so bila kita dah identify this important important ataupun what do we call that, factor, okay, once we have identified this important factor, we can straight away identify whether it should be based on Z effective or it should be based on the shielding effect. Okay, so since we know that dia adalah going down the group, that means dia group yang sama, that means dia going down the group lah. So going down the group, based on the increase in principal quantum number kan. So helium has smaller in size, okay, therefore it is helium has the strongest attraction between the nucleus and valence electron. So strongest attraction means the size becomes smaller. And the ionization energy, the first ionization energy would be higher. Dia terbalik dia opposite trend of atomic size. Okay, so jangan pukul rata across the period increase je. Tak. Across the period for size decrease. But in terms of ionization energy, increase. Okay, betul tak saya cakap? Betul Across the period, size decrease. In terms of ionization energy, it increases. Okay, alright. So it should be helium, neon, and argon. Okay, next. Let's move on to the next. Dia ada suruh bagi mention why ke? Tak ada. Tapi like I said, macam biasa, bagi je lah. Okay, next, let's have Haziq Iman. Haziq?
Yes.
Okay, Haziq. So what will be your answer for B?
Phosphorus.
Phosphorus has the largest ionization energy, is it?
Yes.
Okay, so we're going to start with phosphorus, then
Silicon.
Silicon, and then
Aluminium.
Okay, so do they come from the same period or do they come from the same group?
They come from the same period 3.
Okay, so they come from the same period but different group lah, obviously. Okay, kalau dah across the period, that means definitely will be different group. Okay, alright. So kalau based on the value itself pun dah nampak dah dekat situ that definite bukan value ni kita tak boleh assume macam tu je Okay. Alright, so based on this, phosphorus is positive 5, silicon come from group 16. Okay. Betul tak silicon? Yep. This is group 4. This is positive 3. Okay. It's group 5, group 15, group 14, group 13. Okay, so the higher the Z effective across the period, you have to mention about Z effective. The higher the Z effective, therefore, the smaller the size, and the higher ionization energy. Okay, right, good. That will be it. Okay. Alright, so let's go back to anomalies just now. Dia macam tiba-tiba terbenti tengah-tengah tu. Macam tiba-tiba ada checkpoint yang tak ada dah lah cerita anomalies kan. But suddenly we have commercial break dekat situ. So let's go back to anomalies. Anomalies is also known as abnormality. Okay, yang dia tak follow the general trend. Okay, right. So we know that in terms of first ionization energy, we are talking about first ionization energy, the first electron being removed from the valence shell. Okay, the increase in the first ionization energy across the period is not uniform, so that is why we call it anomalies. Okay, so we know that based on general trend, the ionization energy, the first ionization energy should be increasing. Okay, but we have two anomalies occur in period 2 for group, this is group 2 and group 13, beryllium, boron come from the same period, and same goes to nitrogen and oxygen, they also come from the same period. So this is 15, this is 16. Okay, and also period 3, magnesium come from group 2, aluminium come from group 13. See, sama juga, tapi they are from different period. Phosphorus again 15 and 16. Okay, they belong to group 2 and 13 and group 15 to 16. Okay, all right. So boron and aluminium, both of them come from group 13. Cuma ni period 2, this is period 3. Okay, this is N is equal to 2, this is N is equal to 3. Boron and aluminium with smaller atomic radius are expected to have higher ionization energy. Okay. So based on general trend, kita expect group 13 would have higher ionization energy than group 2. Okay, which are beryllium and magnesium. So by right, these two should have higher ionization energy compared to beryllium and magnesium. But the reverse occurs. Kenapa dia become the other way around? Okay, right. The reason is based on the orbital stability, guys. Okay, so like what we have for chromium and copper last time, remember anomalies tu, kita kena tengok the stability of the orbital. Remember? Sama juga for this one. We have to look at in terms of the orbital stability. Okay, alright. Okay, so let's just refer the orbital diagram here. Okay, so here we have all the explanation. This one you may go through it on your own. Cuba tengok dekat the orbital diagram. Okay, so by right, based on the orbital diagram, it will be easier for you to understand. Okay, so this is beryllium. Beryllium come from group 2, and this is boron. Boron come from group 13. Okay, so this is how the electron configuration, the orbital diagram for beryllium looks like, and this is how the boron's orbital diagram looks like. As you can see, okay, beryllium has a full-filled 2s orbital. Remember, nak stable, dia ada 3 keadaan. Satu, vacant ataupun empty, tak ada electron at all. Secondly, it must be halfly filled, terisi separuh, or alternative to this, we can also have full filled orbital. So these are all considered stable. The unstable version of orbital would be, it is known as, apa nama dia guys? Kalau unstable orbital? Apa
Partially filled.
Yes, it is partially. Partially jangan terconfuse dengan half fill dengan full fill Partially means sebahagian. Half separuh. Partially sebahagian. Berapa banyak sebahagian we do not know. Okay, alright. So depends. It depends on how the the orbital fillings takes place. Okay, so this is beryllium. So as you can see, beryllium atom dia ada full fill orbital, which is this is stable. This is stable. This is unstable, guys. So boron at the beginning, okay, as neutral atom, it has an unstable orbital. Okay, therefore, if it is unstable, you want to remove electron from an unstable orbital. Dia senang ke susah? Senang lah. Okay, sebab dia unstable. Dia unstable. When you try to remove, unstable means energy dia tu energy dia tinggi tau. Okay, energy dia tinggi pada ketika itu. But when you remove the electron from this unstable orbital, it will become stable later on. Okay, so in order to remove the electron from unstable orbital, it will be easier lah, senang. Cuba you imagine macam you ada kawan you yang very cool, calm, stable, okay, mentally prepared, ataupun dia very senang cerita stable lah, okay. Dari segi dia punya karakter dia tu stable je. Susah tak kalau kita nak interrupt dia, nak kacau dia punya emosi, kita nak kacau dia lah, saja nak trigger saja kan. Member relax je. Okay, compared to your other friend yang unstable. Contohnya mentally unstable, okay, dia cepat gelabah, anxious, panic cepat, okay, you trigger sikit je. Okay, dia boleh create chaos dekat situ. Okay, sama juga maksudnya if you try to disturb something that is already stable, you need a lot of energy in order to do that. Sama juga konsep dekat sini sebab this is stable kan. So you want to disturb this, you want to remove one of the electron out, that means you require higher energy. Okay, you boleh remove, so dia akan jadi macam ni. So Be plus, so it become like this, but you need more energy. Okay, you require a lot of energy in order to do so. But for boron, you don't need as much energy. Okay, so you just perlukan tak banyak lah in order to ionize the electron to become this. Tapi you boleh nampak tak, for the second ionization energy later on, boron plus, okay, nak remove one of electron from boron plus, so it will become harder lah. It will become harder sebab this is stable. That is for second ionization energy lah. Okay, so this is only for the first. We are highlighting the first ionization energy. Okay, so the highlight will be the electron in beryllium is being removed from a fully filled 2s orbital. Fully filled configuration is more stable. Okay, alternative to this explanation, you may use orbital diagram to explain. Okay, chemistry tak semestinya kena guna essay. And then kalau boleh avoid guna essay, tak payahlah guna essay tu. Use diagram to explain your answer. Okay, so you may use the orbital diagram for beryllium, okay, and then you label. This is stable. This is partially filled, right? Partially filled. And then unstable. Unstable means need less energy to ionize. Ada, all the contents are there. So you still dapat markah yang sama kat situ. Okay, so you dah ada 2s orbital, ni kan dia cakap 2s orbital, so you have label the orbital 2s. There you go. And then stable, dia cakap dekat sini is more stable. You dah label here stable. Stable. Okay, so you have everything in there, cuma in the form of orbital diagram. Saya personally saya cakap I will go for orbital diagram rather than apa nama tu, tulis paragraph ke apa. Okay, but make sure that you have all the information there lah, unless you lupa nak label lah apalah tu, itu minus lah mak. Okay, so the keyword will be fulfill ni, this one. more stable here. Okay, alright. Faham ke untuk yang itu? Guys, are you doing okay tadi untuk yang tu? Banyak kali saya tanya, are you doing okay? Okay ke?
Okay, madam.
Okay, madam.
Okay.
Okay. Alright. Okay, good Okay, kalau you faham yang tadi, you patut faham yang ini. Okay? So remember tadi kan kita ada anomalies for group 2 and 13. Sepatutnya dia increasing, tapi for group 13 dia suddenly decrease. Okay? And same goes for group 15 and group 16. So we have anomalies for group 15 and 16. Okay, let's just look at the orbital diagram. Sama saja the concept. As you can see, nitrogen come from group 15. Oxygen come from group 16. So this is how nitrogen's orbital diagrams look like, and this is how oxygen's orbital diagrams looks like. As you can see, so buat betul 1s, 2s, 2p, and then this is the what we call that the half-filled orbital of 2p. The half-filled. So label, this is half-filled. Half-filled is stable. Okay, stable means more energy is required to remove the electron. Dah siap. Kena cakap tau, half-filled. You kena cakap half-filled. Sebab stable, it can be vacant, half-filled or fully filled. On the other hand, oxygen is partially filled. So this is unstable. Okay, so in order to remove this one electron out from the orbital, it will require less energy. Okay, the first electron to be removed, the first ionization energy, again, we are talking about first ionization energy. Okay, so the first ionization energy will be lower. But boleh predict tak the second ionization energy? Nanti kalau nak buang one more electron from O plus, it will become harder lah. Sebab now dia dah jadi stable, half-filled dekat situ. That is for second ionization energy. Okay? Alright, so they mention dekat sini, the electron in O is being removed from a partially filled 2p orbital. There are two electrons in the same 2p orbital, thus experience greater repulsion making the electron easier to be removed. So dia ada dua elektron dekat dalam tu. So repulsion dia higher. Okay, this is considered unstable. So in order to remove, to reduce the energy of this orbital, okay, so kita remove the electron. So bila dia remove the electron, the orbital is now become stable. Okay, so dia jadi half-filled guys. But in terms of energy required, it's not that much compared to if not removed from nitrogen. Okay? Faham ya? Alright, so that will be, please remember, anomalies macam biasa will be one of the favorite question, okay, asked in the exam. Sebab student tend to miss out. Okay, sebab apa? Sebab dia hafal trend. Dia hafal general trend. So dia akan miss out. Tambah pula, instead of nitrogen, dia bagi X, oxygen dia bagi Y. Lagilah tak perasan. Okay? So please be careful. Start from the electron configuration. Alright, okay. For this one, okay guys, let's just kita KIV the checkpoint. Okay, so we have few checkpoints from ionization energy, and then and it is quite saya boleh consider sebagai wow lah soalan dia. Okay, agak critical dekat situ dan memang required your understanding, betul-betul faham the concept in order for you to get to come up with the answer. Contohnya soalan ni, and we also have one more question, Miss Nang. This one. Okay, this is what we call applied question. So what you have learned so far, okay, we are going to apply that understanding in these two questions. Okay, alright. So try to complete the checkpoint on your own first, and then we will discuss it hopefully tomorrow. Okay, so try buat dulu. So ini dua question ni memang agak boleh tahan lah, boleh tahan. Okay, it's still doable, tapi kalau you betul-betul boleh buat, that means you really understand. Okay, alright, try buat dulu. Kita nak completekan the IE first, okay. Later if we have time, and then we will come back to this checkpoint. Okay. Tak kisah you ada dapat jawapan daripada mana-mana ke, tak kisah. At the end of the day, you boleh repeat tak balik the answer in exam. Okay, that's why saya doesn't matter you dapat jawapan tu daripada mana ke apa ke, tak kisah. Kalau you faham, then it's good for you. Kalau you tak faham, then it's a loss lah, rugilah dekat situ. Okay, make sure that you are able to recreate the answer in the exam. You faham by heart, you kena faham by heart. So that's why saya tak tanya you dapat jawapan ni daripada mana, you tiru ke apa ke, itu is up to you. You tahu you punya integrity or whatsoever. Okay, as long as you are able to answer my question, saya ada cara untuk nak tahu you faham ke tak. Okay, so I'm not so worried on how do you manage to, macam complicated jawapan ni kan, jawapan ni very complicated ni, somehow student manage to do it. Okay, kita try investigate, dia boleh jawab. I mean, dia faham betul-betul lah. Okay, so whatever it is, make sure that you really understand it by heart, so that you boleh terangkan balik dalam exam nanti. Right? Okay, next. Successive ionization energy. Okay, so this is what I have been telling you in the earlier slide. Okay, saya introduce lagi in this what we call successive ionization energy. Remember, ionization energy, okay, need to be done in order to ionize an atom ataupun to remove electron from an atom or ions. It need to be done stepwise. Okay, it need to be done step by step. It is a step by step process. Dia tak boleh third ionization energy, buang 3 elektron. Cannot be like that. Okay, it should be a stepwise process. Okay, so this is what we call successive ionization energy. So kita ada IE1, IE2, IE3. Okay, so IE1 should start from the atom itself and in gas state. Nampak tak? Gas state. Remove one of its electron, becoming the first positive ion. Okay, this is first ionization energy. For second ionization energy, that means it should be extracted, the electron should be extracted from the positive 1 ions. Nampak tak? And then remove one of its electron, becoming X2 plus in gas state. Then another electron to S2. Sebab dia transfer ni buang electron, minus electron. So transfer to the other side, become positive E. And same goes to IE3, so it should start with X2 plus becoming X3 plus and then plus electron. So nampak tak the electron are all satu, okay, for each chemical reaction. Okay, a positive ion will be formed once the first electron is removed. Okay, a positive ion will be formed once the first electron is removed, like the first ionization energy. Removing the second electron from a positive ion is more difficult due to greater attraction between the electron to be removed and the nucleus. Okay, and therefore the removal of the third and the successive electrons will become more and more difficult progressively. Logically speaking, okay, the more electron you remove, the less repulsion we have. Betul tak? The more electron you buang, that means there is less repulsion in the system. Less repulsion means less shielding effect. Less shielding effect means greater attraction, okay, between the nucleus and the electrons. Okay? Kalau dah greater attraction, that means the ionization energy will become higher. Okay, successively. So maksudnya IE1, okay, kita boleh conclude that IE1 should be less than IE2, should be less than IE3. Okay, sebab sampai dekat sini dah banyak elektron dah kena buang. More electron has been removed. More electron has been removed, that means greater attraction. Okay, greater attraction felt by the electron. Okay, specifically for the valence electron. Okay, Successive IE, successive mean berturutan, okay? Successive IE can be used to obtain clues to deduce the electronic configuration of an element. So we can use this information to deduce ataupun to predict the electronic configuration of an element. Okay, so once we know the electronic configuration of an element, that means we will know the group, the valence electron, betul tak? Once kita dah tahu electronic configuration, automatically we will know the valence electron. We will know the period, we will know the group, the group, valence electron, and semua tu lah. Okay, so this successive ionization energy allows us to predict all the information that I have mentioned just now. Okay, so we will be based on a sudden increase in the amount of ionization energy. To remove an electron suggests that the electron must come from a stable orbital, full or half-filled orbital. Okay, thus the total valence electron can be predicted. Like I said just now, kita nak tentukan. Okay, we can determine the valence electron represent the group kan, remember? And we can also know the period, the location of the kita boleh bagi tak what we will know from this information would be the valence electron. Okay, group period ni, unless dia bagi extra information in the question, then we can also determine the period. Okay, right. Okay, let's apply apa yang dia cakap tadi tu kan. Okay, cuba tengok. Okay, cuba let's start with beryllium lah. Beryllium. Okay, kita start dengan beryllium. Okay, so we have elements. So elements going down here. So we have elements, and then we know that each of the elements, the number of valence electrons. So this number of valence electron represent the group number. Okay, alright. So these are the successive ionization energy. That means the electron has been removed stepwise. Maksudnya remove the valence electron, the first valence electron, the second valence electron, and then setiap satu elektron being removed. So dia tunjukkan sampai 9 elektron dekat situ. Okay, alright. So from this information, we would be able to know the group ataupun the valence electron. Okay, alright. So macam mana nak tahu? Okay, imagine you tak tahu ni lah. You tak tahu Okay, this is X, this is Y, this is Z, this is W, this is M, this is N. Katakanlah unknown. So how do we identify the group of this unknown element? Kita akan base macam ni. Okay, let's go for beryllium just now. Y lah. Let's go for Y. Okay, alright. So Y. Okay, look at the ionization energy. Okay, so we're going to start with 0.9 and then moving on with next. Okay, when this first has been removed, next kita start removing the second electron. Okay, so this is the amount of energy required. And the third electron tu, nampak tak? The third electron, there is a sudden jump. Gap yang terlampau besar. Nampak tak? 0.9, 1.76, and then we have 14.85. Berapa kali ganda naik tu? So this is what we call sudden jump. This sudden jump ataupun big gap ataupun large gap between IE2 and IE3 represent that ataupun shows that this yang sudden jump tu dah start, the electron has been removed, okay, from the core electron, guys. Okay, so this shows that the electron now is being removed from the core ataupun from the inner shell. Dia dah start buang dekat shell yang paling dalam, shell yang dalam-dalam lah. Okay, inner shell. Okay, alright. So bila dah this indicates that, so maksudnya kita boleh tahu that these two are the two valence electron. Faham tak? Dia ada 2 valence electron. Sebab starting yang nombor 3 ni, IE3 ni ada sudden increase, ada sudden jump dekat situ. This sudden jump shows that the electron is being removed from the core ataupun from the inner shell. Okay, alright. Cuba kita try nitrogen. M ni tadi. Macam mana kita nak determine the group number for N? M belongs to which group? How do we know that? Okay, based on the ionization energy given. So kita pun check ada sudden increase tak? Okay, 1.4 to 2.86 and 2.86 to 4.58. And then next electron, the fourth electron 7.48. Then next 9.44. Then suddenly they become 53.27. That is what we call sudden jump. Okay, ada kenaikan yang mendadak guys. So it shows that starting IE6 is already the core electron ataupun the inner electron. So maksudnya valence electron ada berapa? 1, 2, 3, 4, 5. There are 5 valence electron for M. Okay, so that is how we determine the group number or the valence electron from the ionization, the successive ionization energy given. Faham ya? Contohlah ni, beryllium ni tadi. Okay, alright. So, first ionization energy 0.9. Second ionization energy 1.7 C. Suddenly, IE3 terus jadi 14.85. Ini nampak ni, ada graf kan? Si ada graf lagi. This is what we call big gap ataupun huge difference. Okay? So you have to mention that kenapa? Why is it so? Because the third ionization energy yang ini ni, they start to remove from the inner shell. Dia dah start buang pada inner shell. Why is it about inner shell that cause the ionization energy to be higher, guys? Kenapa? Because the closer it is, inner kan, the closer it is to the nucleus, by right, the stronger the attraction. Okay, that explains how the ionization energy for IE3 is the highest as of now lah. Okay, sebab dia dah masuk different n. This is n is equal to 1 lah, for example, and starting ni dah, this is n is equal to 2. Ini dah n is equal to 1. Okay, dia dah inner shell. Okay, alright. So that is why you have to explain in terms of ni. You kena cakap the IE3 is apa nama dia, is the energy required to remove the inner or the electron from the inner shell ataupun from the core electron or yang sewaktu dengannya. Okay, so that would be your and then you have to mention in terms of attraction. Kenapa inner electron ni? You have to mention in terms of attraction. Because it experience stronger attraction with the nucleus. Because dia stay in the inner shell. Janganlah state yang obvious katalah soalan tanya state the group number for this element ataupun state the valence electron for this element. So you pun answer 2 valence electron, betul. Okay, and then give reason why. Okay, you pun pergi cakap because there is a huge difference between IE2 and IE3. For example, okay, with respect to this question, with respect with this information given, you mentioned a huge difference of IE1, IE2 and IE3. Okay, indicating the valence electron is 2. So itu obvious lah, kita nampak lah ini ada kenaikan yang mendadak. You state the obvious kan. That is not the real reason. Okay, that is just to highlight that it has 2 valence electron, but that is not the main reason. The main reason kenapa dia increase is because of the electron is being removed from the inner shell. Okay. Alright, so we have a few checkpoints. So what is the time now? Okay, so just nice. So please complete all the checkpoint, guys, for the ionization energy. Okay, alright. Any questions so far related to ionization energy? So kita habiskan masa kita 2 hours just to discuss about ionization energy. Okay, so there you go. Your 2 hours habis macam tu for your ionization energy. So I consider myself to go really in depth, okay, on ionization energy. So hopefully saya harap sangat that you really understand, okay, this subtopic for ionization energy. Okay, so dia ada contoh soalan yang agak bagus dekat situ for you to try. Okay, so this is also the type of question that normally asked in the exam. Successive, antara favorite question lah. Okay, so element A is located in period 3. Dia dah mention, okay, period 3 in the period table, the following ionization energy of A is shown in the table below. Identify element A and justify your answer. Okay, so first that we can identify the would be the valence electron. So what would be the valence electron? How many valence electrons are there in M, guys?
5.
Okay, so there are 5 valence electrons. Senang aja, cek tinggi ni 22. Ni 6000, ni 22. Alright, so there are 5 valence electron. Jangan pergi cakap 6 pula tau, sebab dia terconsider yang tinggi tu. Jangan. Kita stop dekat sini. Okay, so this will be the last valence electron. Ini dah start and the inner shell. Katakanlah this is n is equal to 3 kan, dia mention tadi. So this is n is equal to 3. Okay, and this kita dah start the inner shell, that means it should be n is equal to 2. Okay, alright, so the group berapa guys?
15.
Yeah. N ataupun period. Group would be group 15. So pergi cari dekat dalam period table tu 15 n is equal to 3 and group 15. Ataupun you may look for, kata imagine there's no period table given, so you may look for the apa nama tu, what do we call that? Electronic configuration. Okay, so you boleh tahu sebab dia dah kata n is equal to 3 and then the group 15 maksudnya there should be 5 valence electrons, so kena construct 1s2, 2s2, 2p6 and then 3s2. It should not end dekat 3s2 lah obviously sebab dia ada 5 kan, 5 valence electron, so we have 2 already, so we should have 3p3. Okay, you should have 3p3. So that is how you construct. Inilah soalan-soalan apply yang kita agak scary sikit bila dia keluar dalam exam. Okay, belum dia tanya lagi quantum number for the third electron in the atom. Okay, give n is equal give the number of electron having quantum number n is equal to L is equal to 1, for example lah, how many electrons having L is equal to 1 as the quantum number. Okay, right, the electron, alamak terbagi tahu pula jawapan guys. So dah ada jawapan lah guys tu. Alright, okay, so that's all guys for today's lecture. Any question?
Madam, ada tak soalan yang minta dia bagi elemen macam contoh yang nitrogen dengan oksigen kan, oksigen lagi sikit kan IE dia.
Betul. Kalau that is based on anomalies kan? Anomalies just now.
Ada tak soalan yang dia minta untuk second ionization energy pula, sebab bila second kan dia dah berubah kan?
Betul. Ada that possibility. Okay, we have that possibility. Dia boleh tanya, okay, in terms of second ionization energy for potassium, for example kan. Boleh. Ada that possibility. That means you have to go for the orbital diagram. To be safe, go for orbital diagram. Sebab from the orbital diagram, you nampak segala-galanya terbuka apa segala. You nampak dia punya bilik, you nampak the electrons and so all of those information will be visible if you have orbital diagram. Electron configuration tak cukup sangat. Okay, sebab remember you kena based on Hans rule kan, you kena fill up singly. So if you have orbital diagram, you can see everything. So yes, untuk menjawab soalan tu ada. Kita pernah tanya based on second ionization energy. At most kita go for second ionization energy lah. Kita tak, rasa saya tak pernah ada experience tanya third and fourth and so on. Paling pun dia tanya write the chemical equation for the third ionization energy. Okay? To be safe memang orbital diagram lah.
Okay, thank you madam.
Alright. Okay, and then one more thing guys, jangan confuse successive tadi successive tadi dengan yang stability nitrogen dengan oxygen itu between this one banyak ni nak cakap tapi tak dapat cakap. Okay. This one, okay, this is between different group, between two different group. Yang ni, yang successive ni, this successive is for one atom. Okay, maksudnya remove the electron from the same atom. Okay, faham tak? For example, nitrogen. Okay, remove the electron stepwise. Remove satu-satu. So maksudnya regardless dia punya orbital diagram dia tu ada that effect, but we know that the inner electron should have stronger attraction. Okay, tapi yang ini tadi dia based on different group. So do not get confused with that. Okay, so this is based on orbital stability. Tadi successive energy ni based on electron being removed. Okay, step by step. Maksudnya dia makin buang, makin lama makin core electron kat situ. Okay, so jangan confuse Alright. Okay, alright. Kalau tak ada question, any more question guys? If there is no question, I think that's all for today's lecture. Thank you everyone for your attention. And Assalamualaikum.
Thank you.
Thank you, Madam.
Thank you, Madam.
Thank you, Madam.